Hello everyone. Today we're going to try a little different explanation on how to wire your signals to the SE74. In a previous video, video number 3 in this SE74 series, I used the system of nomenclature that was adopted by Digitrax and a number of other particular manufacturers, whereby they likened the signaling to a security element, which basically is the turnout with there being two signals at the throat, entrance to the turnout, labeled A1 and A2 for the top and bottom signals on a two-head mast, and B and C for the mainline position of a single head signal, and C being the position of a single head signal on the siding track. That nomenclature does present us with one way of looking at everything, and we will attempt to keep that, but it got a little bit confusing when trying to wire up the SE74 for signals. So we'll keep this in mind, but we're going to take another look at how to set up these signal connections. In this particular situation, this is how I choose to lay out the SE74 and the terminal strip connecting kits. You will recall that the SE74 is capable of managing 16 of single heads or single signal heads. Try saying that real fast. And so in order to do that, we will need to have 8 of these terminal strip connectors, and each connector is capable of controlling 2 3-light signal heads. So with that, we have 16 signal heads that can be controlled by this single SE74. The way I have set these up, I've connected the ribbon connectors to the pins at the bottom of the SE74, run them up through holes in the board, run them up to the back, and connected them up as we discussed in the video number 3. You will recall that on the SE74, there are these 4 pin connectors, and they're labeled S1, S2, S3, and S4. You can't see them on the SE74 when it's mounted here, but on this diagram that is provided in the SE74 manual from Digitrax, you can see how those 4 connecting sets of pins are numbered. So what we have done in this particular layout is to connect the ribbon connectors to each set of 4 signal connectors. Each ribbon from the set of pins down here, S1 through S4, each ribbon is capable of managing 4 separate head connections with 3 lights on each. If you refer to the previous video, you'll note that there is a twist in each one of these ribbons, so that in this layout here, the terminal strip connector on the right has the brown wire closest to the screw terminals. The terminal strip on the left has the brown wire furthest away from the terminal strip connectors, these screw connectors. I've labeled on here how I've got them hooked up. Doesn't have to be laid out like this, but this happens to be the way I put them together. This set of connectors is associated with driver 1, which is connected to, at the bottom down here, to the S1 connector. So there's a ribbon cable running from the S1 connector up to these two, and it is twisted so that opposite sides of this are connected to the terminal strips. And that same layout is carried all the way through this setup on this board. I've set up a number of signals on both my club layout and my home personal layout. This one happens to be on my home personal layout. I've set them up like this, and it makes it much easier to work with because you have it all laid out in advance. You have these wired. All you're going to do now is run the signal wires up and connect them to the screw terminals. The way I have this labeled, this set is from driver 1, or S1 on the bottom down here. This one is driver 2, or S2 on the bottom, driver 3, driver 4, etc. On this particular layout, which is actually in place on my home layout, I am operating turnout number 14, 15, and 16 with these particular terminal strips. We're going to get a little bit more into that in a minute, but each of these terminal strips is capable of running 2 heads for a total of 4 per driver. One important point to make at this stage is that each individual head control, there's 2 on each terminal strip, 4 on each ribbon connector. Each head control is capable of being operated totally independent of the others as far as giving it commands and giving it issues as to when the lights are red, yellow, green, etc. And all of that is determined by what we put into JMRI later. As I said in a previous video, you must have some type of software to control the signals that you're mounting on your layout. The SE74 by itself has no ability to determine what lights should be on. You send switch commands to the SE74 to tell it which lights to turn red, green, etc. So we are using JMRI to control our signals. With JMRI, it is very easy to set up a complex signal system by using the setup panels that are provided in JMRI. We talked about that in video number 3, and I'll go over it a little bit more in this particular video. But the important thing I want to get to now is how you determine which of these 4 heads is being controlled by which commands. This is the important part that was a bit confusing if you try to stick with the Digitrax terminology where you use A1, A2, B, and C as the names for these particular heads. It gets a little awkward to continue that because you're not always going to be using signals that are associated directly with a turnout. Each one of these is capable of running a signal head no matter where it's located, and technically you could connect this to A1, this to A2, this to B, and this to C. It doesn't matter. What matters is how you then tell JMRI to control that particular head through the software. So what's really important is how do you associate the commands, the switch commands, going to the SE74 in such a way that you know which one of these 4 lights on each ribbon is going to be controlled. And that's where we come up with our table that we made in the previous video 3. I introduced a table, which I happen to do in Excel, but you can do it at any table. You can draw it out on your hand, on a piece of paper, whatever you want to use. But you should lay out a grid system like this so that you can keep track of what you have assigned to each of the switch command addresses. You will recall from a previous video on the SE74 that you will probably need to set the base address for the SE74 to a number that will not conflict with any of your other switch commands. If you go back, you will see that we set this particular SE74 to the base switch number of 325. When you have done that, the first 4 addresses refer to switch commands to control the turnouts that you might be operating from the SE74 down here on the turnout control strip. You can refer to a previous video on how to do that. We're not going to address that today. We're only going to address signaling. But what is important is that once you set the base address of the SE74, the first 4 numbers will be switch commands to operate tortoise turnouts or whatever kind of turnout motor you're using to either the closed or the open position. In this particular setup, I'm not using any tortoise commands here because all of the switch control motors on my layout are the SMAILs, and they each have their own decoder address. So I don't need that function of the SE74. I'm only using the signaling function of the SE74 to operate signals on this layout. So in this case, we have to recall that the first 4 numbers operate turnouts, and then starts the control numbers for the signal commands, and they run up through, in this case, 360. And what we now need to take a look at is the fact that if you set up what we have shown here on this board, where this particular driver is driver 1, these first 4 are from driver 1 or the S1 connector on the SE74. When you set it up like that with the reversed ribbon that we talked about before here, the brown wire closest to the terminals, we now will get which ones of these are going to be addressed by the first 8 switch commands in our table. These are all associated with switch command capability 1. I'll say S1 because that's how this is numbered down on the SE74. So S1 is the first set of commands. It encompasses 8 switch commands, and they go in order as we assign them to a light. They will go in order from, if set up like I have it here, this is the first one, which would use up commands 329 and 330 right here. This is the second one, which would be commands 331 and 332. This is the third one, which is commands 333 and 334. And this is the fourth one, commands 335 and 336. If you watched the previous video, you might have seen a slightly different layout as to how these were labeled. This would have been A1 and A2, but I think in the previous video we had labeled these B and C. The problem was that we didn't make it clear that you still have to go use the numbers that control that particular head connection. So remember, there's 4 connections, 4 heads, and they take 4 sets of 2 commands each. And if you go back, you'll see how we set those up to identify a particular head that was being placed on our diagram, and we assigned 2 switch command numbers. We don't need to know what those switch command numbers do. All we need to know is that those 2 switch commands are associated with the control of this particular connection right here, the first one. So 329 and 330 are assigned to the signal head that is connected to this one. And as we go around like that, 1, 2, 3, 4, they go right down the table, so that the first connection is 329, and it goes right on down, taking them 2 at a time. And the way I have set them up, for example, I label these 2, 329 and 330, are associated with my turnout number 14 A1 signal head. So that's what I have put onto this table. I put in the table that 329 and 330 are used to control turnout number 14 A1 head. Likewise, the next ones control this one, the second one, as we go around, 1, 2, 3, 4. As we go around, the second one will control head number 2, A2. The third one will be head B, and the fourth one, head C. You don't need to call them A1, A2, etc., etc. You can give them other names. For example, if you're controlling a signal that is between 2 block boundaries, then you might want to say, this is signal block 101 into block 202. That way you know what each set of these control numbers is associated with. Again, each one of these screw terminals operates a single set of 3 light signals, and JMRI takes care of what codes need to be sent to operate those. So here are the codes that go with that and how they've been assigned, in this case for turnout number 14. Likewise, up here I've got turnout 15, and they're associated down here because this is the 3rd driver. They aren't the next one down. I'm now using 15 is assigned to the 3rd driver, and then 16, which is down here, happens to be the 2nd driver. Why? I don't know. It was just the way I set it up. You can set these up any way that works for you, but you need to keep a table like this so that you know what you've assigned each one to. And you saw how we put those into JMRI. Again, I'll briefly go over how you assign these signal control numbers to each head, but the important point is that which control numbers operate which of these screw terminals. That's the part to get straight. So in this case, we now have these 8 numbers control those 4 signal heads. The next set, if you go to driver number 2, then driver number 2 is going to have this set of control numbers to operate the 4 heads that you see right here. 1, 2, 3, 4. Again, it's determined by where the brown wire is. Is it close to the terminals or is it away from the terminals? And since each one of these is set up the same way, The one on the right has the brown wire closest to the screw terminals. The one on the left has the brown wire furthest away from the screw terminals, and that is the reversal of this ribbon that allows you to get all of these commands from one 10-wire cable. So again, here's S2 connected to driver number 2, and the numbers 337 through 344 will operate 1, 2, 3, 4 in that order, going counterclockwise around the way it's been installed here. So that takes up those set of numbers. Likewise, we would do the same thing for S3 and S4. This would be S3, this is S4. And now all you have to do is to run the wires from your signal heads and connect them up here. One important thing that I would mention before you start installing things permanently, I would test each of these with a signal light and give commands to the SE74 to make sure that you've actually got these all hooked up right. I've come across cases where I didn't get the connector correctly onto the pin, other things like that. Maybe I lost track of which one was hooked up to which. It would be a good idea to test everything before you put it onto your layout in a format like this one is here. And again, it looks complicated, but by laying it out in this format, you can see exactly which wires are hooked up, and you can keep track with the table as to what control numbers you're assigning to each control head. Each control head requires 2 numbers to operate all of the lights on the head. So you'll use up 8 numbers for each set of 4 signal heads connected to the S1, S2, S3, and S4 connection on the SE74. Okay, let's review now how to hook up a signal head to each of these terminal strip connectors. This is an example of a signal head that there's only one head on the mast. It has typically 4 wires. One of them will be the common, and then there will be 3, one for each of the colors. Most of these are common anode, and then the cathode is the colored one. Doesn't matter, I'll show you how to hook it up on here. As I explained in a previous video, I do not just use the wires off of these individual masts because they're too fragile. I connect them to, in this case, AWG20 solid wire. I solder them together and then cover them with heat shrink tubing so that there's more stability to the signal wiring and less chance of breaking the wiring while you're hooking them up. So okay, so we have these 4 wires. If you recall from a previous video, the common wire for whichever one of these if you're using this particular terminal strip, you connect both of the common wires, in this case the black wire, to this particular bottom, this particular screw, both of them. Always connect the 2 together, whether you're hooking all of them up to this one or this one. You still connect the common wire or black wire to the this screw terminal right here. The instructions that come with the terminal strip mounting kit show how each of these connectors is labeled, and the one that we're going to connect the common to is connected is called common low. I hate the terminology low and high because we've got those confused in the past, and I'm going to try to avoid using that terminology here. But we almost have to in order to talk about where to hook these up. Again, for each of the two separate heads that you're connecting to these individual screw terminals, always connect the common wire for either signal head, always connect it to the common low signal. I can't get into why it's that way. It has to do with the logic of the signals being sent on that 10 cable ribbon connector cable, and I don't fully understand it. I just know that this works. So whatever you do when you're connecting two heads to these two screw terminals, always connect the common from each head to this low common, which is the screw terminal in the middle there. Now, if you happen to have a dual head signal, such as this one, then most likely you will only have one common wire for all of them. In this case, it's still black the way I wired it up, so I have one common black for both of the double heads on the mast, and that black will still get connected to this particular screw terminal right here, and then the appropriate colors will be connected to the others. Again, the sheet that comes with the terminal strip connector instructions shows you which colors to connect where. And the top one up here is not used on either of these terminal strips. It's an aux signal. I don't really know what to do with it. It's immaterial to what we're attempting to do. But for each signal head, you will attach the red, yellow, and green wires to the terminal strips as shown on this diagram that comes with the terminal connector strip. So, and it's the same on both of them, green, yellow, red from top to bottom. So green, yellow, red, then the common. The top one is not used. So there's three unused screw terminals on this strip. The top one on the upper screw terminal, the top and the bottom on the lower set of screw terminals. And then the three colors are connected green, yellow, red as you go down. Green, yellow, red, green, yellow, red. And the common for all of those is connected to the bottom common connector on this top screw terminal. And again, you can look at this and always connect both commons here and connect up the red, yellow, and green as appropriate there. You still have individual control over these with the numbers that we're going to show, but that's how you would connect up your individual heads. And remember, at this point, we are not going to be concerned with where you put the head, whether it's A1, A2, B, C, or some other location of the signal, such as a boundary between two blocks. We're just connecting one terminal head to each of these screw terminals according to the directions here, where you get the common connected here and the colors as appropriately shown here. That covers how to connect up the lights. Okay, let's quickly review how we connect the individual signal heads to JMRI so that we can control them. Remember that what we're going to be doing is associating the terminal strip connector here. Say this is going to be the first head that we connect, and we use this one. This will be first, second, third, fourth, and the numbers that we just talked about a little bit ago will be connected to this. How do we control the signal that is connected to that terminal strip? And this is how we accomplish that particular function. Again, recall that the numbers that were going to be associated with this are for the S1. That was the first one. And so our first numbers will be 329 and 330. And we will use that to set up our first signal. First thing we have to do is go up here to the Tools menu on the control panel and choose Tables and then Signal Heads. And that will bring up this table that gives us the list of all the signals that we currently have in the system. Right now, there are none listed. So we're going to install one, and for our purposes today, we'll just call it, I don't know, head 1, I guess. So we collect add, and up here in the upper left-hand corner is a new box that just opened up. We can bring that down, I hope. Well, I didn't mean to do that. Let's bring this down where you can see it. And what we're going to add, if you recall from the previous video, we have to select what kind of signal head we're going to add. In this case, we're going to add an SE74 aspect signal. That's what's controlled by the SE74. So we choose that as our type of signal at the top up here. Then it says give it a username. So we will call it head 1. And in order to create this, we must assign the first of the two numbers. And from our sheet, if you remember, the first number was number 329, the second is 330, and that will be associated with our first head. So we'll type in here 329, and then down here 330. Once we have accomplished that, we can create the light. What we're doing now is associating these two numbers with the control S1 on the SE74, which is associated with that first terminal strip connector, this one right here. Okay, so now we've associated those two numbers, 329 and 330, so we'll go ahead and create that light. And you notice over here in the table, we now have a username of head 1, and we can see that it has been assigned the two numbers 329 and 330, which control that particular head. So at this point, we're just going to review setting these up rather than making it a whole lot of logic, which I explained in a previous video. But so we're done with this creation block. We can get rid of that, and we can hide the table for the signal heads at this point. Now, what we want to do is to put that signal head onto our layout diagram. So we go up to signal head icon, and we use the drop-down box, and there we see that we have the name of that signal we just defined in our table. So we'll click on that, and we can come down on the layout plan and put that wherever we want by holding down the Shift key and left-clicking with our, well, I got to hit the right button, left-clicking with our mouse. Now we've put a signal light on there, and the point that I'm emphasizing today, that we haven't called that an A1, an A2, a B or a C or anything else. We're just hooking it up to this particular terminal strip on our layout board where we've put all this together. You can call it A1 if you like. You can call it any number of different names. We called it head 1. It's associated with that particular terminal strip. Okay, so now we've got that light installed on our diagram, and we can actually control it through JMRI. If we come up here and choose from the Tools menu, Tables, come over and get Signals and Signal Heads, and bring up this table. There again is the light that we defined and assigned it right there. Put it on the diagram, and you can see that if we come over here to where the appearance can be controlled, you see that if we use that drop-down box, we can say make that light be red, and sure enough the light goes to red. We can make it be green, we can make it go dark. Whatever we tell it that we want it to be, that is controlled now by JMRI. Okay, so now what we want to do is make it do something. Okay, well, where would you like to put that? You can put it anywhere. We can put it down here as an A1. We could put it there as a B. We can put it over here as a signal between the blocks, block 101 and 102. We could put it almost anywhere. For right now, let's just say, okay, we're going to move this light down and we're going to put it in a position that we would consider the B position for this signal complex right here, where you would have A1 and A2 on this side, B and C. Okay, we'll just put it over here. Okay, does this light tell us anything right now? The answer would be no, because you can turn this turnout back and forth and nothing happens, because we haven't told the JMRI program what logic we want that light, that signal head right there. We haven't given it any logic. We've told it who it is, we've told how to control it, but we haven't given it any logic. If you remember from the video 3, we assigned logic to this by right-clicking on the icon, coming down to the Edit Logic position, which brings up this block right here where we can fill in what we want that light to do. Okay, remember that one of the things you have to do is define where is the light located. And you've got on a single block, like between two blocks, on the main leg of a turnout, on the diverging leg of a turnout, and the fourth one, which we never really talked about, is the facing point turnout. We won't talk about that here either. Okay, so in this case, this light, this signal that we just moved down here to the B position, is on the main leg of a turnout. In other words, it's on the straightaway. It's on the main leg. So we'll click on that, and that will change some of the boxes down here that we have to fill in. So the first box is, what blocks will it protect? Well, just for the heck of it, we're going to say we want to protect block 1325, which is up here at the top. That says that if this block is occupied, that light will be red. We also have here the next choice is that the light is red when the turnout state is thrown. Well, which turnout? Well, this turnout right here. That turnout number is turnout number 325. So we drop down box, we find turnout number 325, we select it, comes up in the box, and now we have identified what we want to happen here. Let's suppose we add one other one, that if block 106 is occupied, that would also be red, so that if it would otherwise be green, except there's a train sitting over here, it'll come up red. So up here we say protect sensor, and we're going to add 106. So now we've got this all defined on how we want that signal to behave. So now we're going to apply it, and notice that immediately it turns green, because that signal is, or that turnout is set for the main line, straight ahead, it's clear, There's nothing parked in block 1325. There's nothing parked in block 106. So we're done with the definitions here, and we can close that. Now, if we come up and make this turnout change to the thrown position, look what happens. The light turns red. Okay, so now it's responding to the thrown, to the switch position. What if we make the tracks occupied? So I'm going to bring up the sensors, and I'm just going to come down here and say block 1325 is occupied. So I'm going to make that active. Now the turnout is occupied. The light turns red even though the turnout is set for straight through. The same would be true if I had 106 still occupied. So if I make that occupied, we get red. If I go back and unoccupy block 1325, that light is still red because we have said we don't want to go past here if there's a train sitting in this block down here, because we don't have a light right now at the beginning of that block. So this light is protecting both the block that the turnout is in and the block that follows. So we have set up this light to do what we want for where it's located. And we did that quite easily through that setup box that told us what conditions to consider for making it red or green. Okay, I'm going to make that block no longer active, and that was 106. So I'll get rid of that right there, and so now the light is green again. Okay, so now let's just say that, whoops, that wasn't where we wanted that light. Okay, where do you want it? Well, let's put it down here to indicate the movement between block 102 and 101. Okay, well then properly we need to change, because right now it's still going to respond to that turnout position. Well, we can redo that. Just right click on it, edit logic, and let's redo these things. For example, let's get rid of this choice up here, which is block 106. We're not going to monitor that anymore. And the way you do it is you go up to the top and there's a blank up there, and you choose that. Okay, so that then gets rid of that. You don't want it to monitor block 1325. All you want it to do is monitor block 101. So we're going to then change this so that it monitors only block 101. And this is now no longer on main leg of a turnout, so we're going to change this back to on a single block. So now the only thing that we're setting this light up to do is monitor whether this block is occupied. So we have it all set up. That's the only thing it's going to do. So we'll apply it, close it, and we're all set up. It's green because there's going from this block into this block. There is no train sitting in block 101, so we're good. Let's make block 01 and 101 be active. In other words, there's a train parked in there. So we come down to the sensor for that block, which happens to be sensor 101, and make it active. Notice that this light now goes to red, saying you can't go past this light. There's a train in there. So what I'm trying to demonstrate with all of this activity here is that regardless of which one of these terminal strips you connect the light to, whether it's this one, you can set it up to monitor any particular one you want. It does not have to be A1, A2, B, and C. Those are terms that are convenient. Use them as you like. I happen to just label them that way so that I know which one is which. I can go in and hook up lights any way, signals any way I want. Likewise, we could have moved this signal down here and put it right there. Notice it's not the right logic because it's still monitoring this block back over here. But you can go in, right-click on that, choose logic, and go change. This would now be on a diverging leg, and the signal that you want to monitor, or the turnout you want to monitor, is 325. That's okay. That's where it is. And now instead of block 101, you want to do block. Well, the thing is out where you can't see it over there, but you want to monitor block 1325. So now we've got 1325 and signal 325. Okay, so we apply that, and look, now it goes red again. So what we've now done is set it up as the C light. It's working just fine as a C light. All because we're still connected to that same place on the terminal strip. It's all in how you define the logic. Once you determine the light, put it on the, define it in your signals table, put it on the diagram, you can make it any logic you want regardless of where it's put. You can put that light back over there. It's the way it's set up. It's still going to tell you what turnout 325 is doing because we didn't change the logic. We just moved the light. So the whole function is you can put these signal lights anywhere you want them and then define the logic that makes them operate by filling out this box on JMRI. And that's what makes this whole system work. So that's just a quick review of how we hook these up, and hopefully makes it a little more clear as to how to relate JMRI to each of the terminal strips, each of the heads that you connect to the SE74.